Hey guys, I'm back for another video. Today I'm just going to solve the 11 hardest questions on the Math Module 2 Practice Test 5 that the SAT board provides. I'm going to be solving all of them pretty much live, so all my reactions to the problems and all my solutions are my first solutions to the problems. I think one or two of them I solved before, but pretty much every single problem would be my live solution. One of the problems I got interrupted, so I had to stop the recording. Or I had to continue it, but I just redid the problem after, and you'll notice I have a cut, but all the problems other than that are completely live, same recording, so I want you to make sure this is legitimate, and it's actually me thinking. Yeah, thank you. Have fun watching. Let me know what you think in the comments, and learn now.
17. Which expression is equivalent to ax cubed plus 8 minus x cubed minus 2. So quickly looking at this, I mean, these two obviously factor out, so we get 7x cubed, and we got negative negative, so plus 10. So the answer would be B. Okay, question number 18. 4 times the square root of 2x equals 16. What is the value of 6x? So then 6. So let's say, we look here. Our value is clearly 8. So then 6 times 8, 48. Our answer is B. Number 19, for which of the following tables are the values of x and their corresponding values of y solutions to the given inequality? So we get the inequality 2x minus y is greater than 883, right? So let's zoom out a bunch, right? Because obviously we're going to be out. So we see we have this line right here. So the problem is it's a little too big, right? So we're just going to have to look at our tables. So if we look at our table, 440 for A, 440 is 0. So then 2 times 440 plus 0, and that's 880. So that doesn't work right away. For B, we have the same table, so that doesn't work. So A and B are wrong. For C, we see 442. That probably does work. But 440 times 2 minus 2, or plus 2, that would work. Not work, sorry. So C is wrong. That means B is our answer. Okay, question number 20, 5y equals 10x plus 11, negative 5y equals 10x plus 11, negative 5y equals 5x plus 21. So what is the value 30x when we solve for this equation? So if we zoom in, we're still far away, we see that we have here, this is our x value. Let's multiply this out by 20. I mean 30, and we get 20.001. It's probably just 20. The problem probably is just rounding error right here, but it's not a big deal. Let's go to 21. Question number 21. A rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. The diagonal of the rectangle is twice the length of the shortest side of the rectangle. The area of the rectangle is 1089 times the square root of 3 square units. What is the length in units of the diameter of the circle? So we have a circle here, right? And we have an inscribed rectangle, right? And the diameter here, the diagonal here is 2x, and the side here is x, or the shortest side is x, sorry. So then now we know that it has to be a 30, 60, 90 triangle, because we know that it's a rectangle inscribed in a circle, meaning all these are right angles, and this is x, this is half of this. So this would be 30, and this would be 60. So that means this angle, this side would be x times the square root of 3, right? That means the area of this total square would be x squared square root of 3, right? And looking at this, we can find x by taking the square root of 1089, right? And that's 33. So that means x is 33. That means 2x equals 66, right? So our answer is 66 because we look at this 2x, same as the diagonal. 22. Rectangle ABCD and EFGH are similar. The length of each side, EFGH, is 6 times the length of the corresponding side of ABCD. The area of ABCD is 54. What is the area in square units of EFGH? So we know ABCD is, let's say here, ABCD. I mean, let's say it's a 1 and 2 here because it doesn't really matter for us. We know we have EFGH. Oh, well, we know that our area here is 54. So let's just make something up. We have 6 times 9, right? So the length of ABC, the area of ABCD is this, 54. But then each side of EFGH is 6 times larger. So this would be 6 times 6, which is 36, and this would be 54. So to find the area, it's just 36 times 54. 1,944. So our answer is D. Okay. Question number 23. Which expression is equivalent to 42a over k plus 42ak? Right. So what we can clearly see is this is the same as 42 times k squared over k. Right. And then we could factor this up here, 42a, and then add this here, plus 42. So then quickly, 42a, because originally we had 42, a over k. And then here, this is the same as 42a, a times k squared plus 1 over k, right? And this is just D. So our answer is D. That's great. 24. Which quadratic equation has no real solutions? So we're just going to try out all these equations. Plus 14x minus 49 equals 0. So that has a solution. Then our next one's plus 49 minus 14x. Then we see that has a solution. Next we have 5x squared minus 14x minus 49. And we see that has a solution. And finally we have 1 plus 49. And we can see that this one won't have a solution, obviously, because the other ones did. So we can kind of just use elimination either way. But so we see the answer is D for 24. 25, P of t equals 260 times 1.04 to the power of 6 over 4 t. The function P models the population in thousands of a certain city 2 years after 2003. According to the model, the population is predicted to increase by 4% every n months. What is the value of n? Right, so we see that 1.04 is essentially 104%, right? So that means increasing by 4% would be when 6 over 4t equals 1, right? So then t would just be 4 over 6. But then we know that this is years, right? So 4 over 6 years would obviously be 2/3 of a year, which is 8 months. So our answer would be A, 8. Okay, moving on to 26. A circle in the xy plane has a center at -1, -1. So let's draw this, right? So undo everything. All right. We have, let's draw our xy plane. I think this is better to draw, even though you do have an xy plane in Desmos. This is y, x. And we have -1, 1. So this is our circle, right? We don't really know how big it is yet. Then line T is tangent to the circle at 5, -4. So 1, 2, 3. 1, 2, 3, 4. So that this circle reaches this, right? So boom, something like that. It'd be 5, -4. This would be -1, 1. Right? So what's important is we're gonna need to find the line T, right? So what is this line, right? And this line is obviously at a right angle to this. So if we find the slope of this, we can find the slope of this, right? So to find the slope of this line, we see that we're going 6 across and we're going down by 5. So our slope is -5 over 6, right? So now we're gonna see what other line matches the slope -5 over 6. Okay, so or how many times we can subtract this from this. So really quickly, let's find our y equals mx plus b. So y equals mx plus b. Right. Our slope is -5 over 6. And we have the point 5, -4. So let's plot this. Y equals -5 over 6x. And then it goes through the point 5, -4. Oh, and we see that it's almost there, but we're down by, it looks like 1/6, plus 1/6. Okay, right away we see that this intercepts. So now we can just plot all our points. So 5. This is not on our thing, so A is not our answer. 4, 7. This is not our answer. 10, 2 is not our answer. 1 is not our answer. Oh, wait, shoot. Okay. I messed this up, and that's okay. Alright. I'm gonna delete everything, and we know the slope of this is -5 over 6. So that means our slope would be 6 over 5. Sorry. So our slope is 6 over 5. So y equals 6 over 5x plus b. So 6 over 5x, right? And now we have to get this to line up with this point, right? And at 5, we have 6. So we just have to subtract 10. Sorry, guys. Too old for this. 0, 6 over 5. It's not on this. 4, 7. It's not on this. 10, 2. It is on this. So our answer is C. Okay. That one took a little longer just because I messed it up. But that just shows you that it's okay to make stuff wrong on the actual test. It doesn't mean you'll fail. Okay. So let's delete everything. Let's read 27. For an electrical field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength and the area of the surface. A certain flat surface consists of two adjacent squares. The side length in meters of the larger square is 3 times the side length in meters of the smaller square. An electric field of the strength 29 volts per meter passes uniformly through the surface, which is perpendicular to the electric field. The total electric flux of the electric field through the surface is 4,640 volts times meters. What is the electric flux in volts times meters? So we know flux equals product of field strength plus times area, right? And we know our strength is 29. Okay, and we know the side length, a certain flat surface consists of two adjacent squares, right? And we know that the side length in meters of the larger square is 3x, and this would be x. Okay, so we know that the flux is 4640. Oh no, sorry. The total electric flux of the electric field through the larger square. So the total electric flux is 4640, right? So we have to find the electric flux through the larger square, right? And we know that the larger square's area would be 9x squared, and this would be x squared, right? Okay, so this is really easy, guys. This question is just giving you a bunch of mumbo jumbo that you don't really need to care about. All that matters is this square is 9 times the size of this square, right? And the flux is proportional, right? So that means it's a 9-to-1 ratio, right? And this is divisible by 10. So it's going to be 9 times 464 to 1 times 464, right? So the larger square would just be 9 times 464. And our answer is 4,176. And that's the answer. And that's all the last 11 problems. Thank you.